Good day, everyone. Let's join revision for the essay question. And today we are using MRSM questions 2012, which is question 7, related to the conductivity of electricity of substances. Now, I'm going to share my screen. Okay, I hope you can see this clearly. This is the question 7, actually, that you have already completed. Now, let's move on. The diagram shows two apparatus set up. What is the purpose of the diagram shown? Keywords again. I always emphasize on identifying keywords. So what is the keyword? Okay, the keyword number 1, to investigate the electrical conductivity of substance S and substance T. Now, when we are talking about the word electrical conductivity, the terms that should come into your mind will be free moving ions. Okay, I repeat. When there is free moving ions, the substance can conduct electricity. Okay, this is the keywords. Now we look at the picture. Can you see this part? Look at the bulb. The bulb is the part which shows you whether a substance can conduct electricity or not. Okay, now in this substance S, it is shown that the bulb does not light up. For substance T, the bulb lights up, meaning to say the substance S does not conduct electricity, but the substance T can conduct electricity. Okay, now, did you see this to be a solution? To be a liquid? This is a liquid. Okay, can you see this part? A liquid. Therefore, when you are going to, based on the observation, you give example of substance S and T, the substance that you are giving should be in liquid state. Okay, for example, for substance S, what are the substances that cannot conduct electricity? Okay, you can always name any covalent compound, okay, which is in liquid state for S, any covalent compound. For example, now what can be your answer? Number 1, you can put the ethanol. You can put ethanol, okay, or you can put the tetrachloromethane. I am giving you some examples where you always see that is familiar to you. Don't give some examples where you are not familiar with it and you have problem in writing that. Okay, so now this is compound S. Now what about compound T? Compound T, of course, is the substance. This is T. It will be an ionic compound, any ionic compound in liquid state. Now, your example can be any type of salt solution. I am using the word solution, any alkali or any acid. Okay, example, you can put the easiest one, the sodium chloride solution. Okay, number 2, you can put it as the hydrochloric acid. If you are putting sodium hydroxide, I don't say that you are wrong. You are correct. Okay, so this is the answer for part 1, A1, where when you can suggest one of the S and one of the T correctly, you get 2 marks. Now go for the explanation. Second part of the question, explain the above observation. Okay, now what are you going to explain? Meaning you are going to explain why S does not conduct electricity and why T can conduct electricity. So we are going to relate to the keywords that I mentioned just now, which is the free moving ions. Okay, now can you see? Explain the observation. This part is the observation. Okay, so now when you want to explain, we relate to the aim of the experiment again, which is to investigate the electrical conductivity of substance S and T. Okay, now therefore you are going to relate the bulb does not light up to the conductivity of electricity, meaning to say you are going to have your point 1S. S does not conduct electricity. Okay, now you can further explain, or you can say T. You can say that S does not conduct electricity, but T can conduct electricity. Okay, now we are going to write our reason why S cannot conduct electricity. Then you can say for S, there is no free moving ions. But for T, then you are going to tell the same story, but for T, there is free moving ions to carry charges. Okay, now we can write furthermore. Why does the S does not has free moving ions? Then you can say S exists as neutral molecules. But T consists of okay. So can you see this one? First part, you are going to explain the observation. Part 1, you are going to tell that the S okay, the S does not conduct electricity, but T can. Okay, this one we relate to the electrical conductivity. Now next, we are going to explain why S conduct electricity. No free moving ions for S, but for T, there is free moving ions. If you want to tell further, you can say the S exists as neutral molecule, but T exists as ions. Okay, so you can always put the S here, the last point above here, no problem. But as long as all this are there, okay, so this is your answer for part A, 1 and 2. I hope you are following me. If you have any problem, you can always text me. Okay, now let's move on. Next part of our question. We are now going to part B, where in part B, we are talking about this, the apparatus set up for the chemical cell, which consists of zinc electrode and copper electrode immersed into sodium chloride solution. Okay, first of all, we are going to analyze this diagram. Now, which is the negative terminal in this case? Which is the negative terminal? Now, I hope that you get your answer as the zinc as negative terminal. The zinc as negative terminal. Now, one is zinc as negative terminal, the zinc electrode. Okay, number 1, we get that it is the negative terminal. Why is that so? I hope you get the reason. It is because zinc is more electropositive than who? We are comparing the zinc the zinc and the copper. We are comparing these two. So when we are telling more electropositive, we are actually comparing to copper. Okay. So now when we are talking about negative terminal, it serves as the anode. So zinc is the anode, and anode undergoes what reaction? As what I've mentioned previously, anode always undergoes oxidation. Okay, so please take note. The 4 points that you must have when you analyze this diagram. First of all, you are going to get which is the negative terminal, which is the zinc negative terminal. Now, the reason why is it a negative terminal? More electropositive. Compare with what? Compare with another terminal that we use, the copper. Now, if it is negative terminal, this is related actually. This one, and this one related. Okay, these two, they are related. Can you see? When it is negative terminal, it is the anode. It is the anode. So anode also relate to the next one, where when it is anode, it relate to oxidation. This is the relationship. Okay, now we move on. Indirectly, we know that this copper here will be the positive terminal. When it is the positive terminal, it is the cathode. And what process undergo at cathode? It is actually the reduction. Okay, now what we have to know here is that which is the species or the substance that undergo reduction. Then we are going to look for the cations. Cations. Cations always attracted to the cathode. So now we are going to look for the cations. From where we get the cations? Of course, it is from the sodium chloride solution. So now from here, from the sodium chloride solution here, okay, we are going to state the ions that present in the electrolyte. Okay, the ions that present in the electrolyte will be the sodium ion, the hydrogen ion, and of course the chloride ion and the hydroxide ion. Now in this case, we are not going to look at these two. These two, we are not going to look at it. Why? Because we want only the cations. So out of the cations here, the sodium ion and the hydrogen ion, which is lower in the electrochemical series, and we will find that the hydrogen ion is lower. Therefore, this hydrogen ion will be selectively discharged. When it is being selectively discharged, what will you obtain? You are actually getting the hydrogen ion gains electron to form hydrogen gas. Now, why gains electron? We refer back to the definition of the reduction, where in reduction, the substance will gain electrons. Okay, now balance up the equation. Can you see a 2 on the right hand side here? A 2, so I put a 2. 2 positive, 2 electrons. Okay, this is what we call it as the half equation. Can follow on? Okay, now if we were to write about the observation at the copper electrode, at the copper electrode, we want to talk about the observation, then this hydrogen gas will actually give you observation. Okay, I'm going to write it up here. Okay, now if we are going to talk about the observation, this one, what is the color of the hydrogen gas? Okay, the color is, yes, correct, it's colorless. So our observation will be colorless gas is produced. Okay, now from here, I can relate to one more part of the question where we want to write the chemical test of the presence of hydrogen gas. See how the questions is being related. Of course, at first, from the picture, we identify the negative terminal, we identify the process that happened. Then we talk about the positive terminal, which is the copper, which serves as the cathode. Because of the cathode, the ions will be attracted to it. So from there, we are going to select the ions which is selectively discharged. How to determine, for those who have forgotten, we are going to look for the ions which located at the lower position in the electrochemical series. Okay, then you write the half equation, and from there you relate to the observation. Okay, now one part that I have left out just now, when we are talking about the zinc electrode. What is the part? Oh, I would like to show you about the half equation. I would like to show you about the half equation that happened at the anode. Now, just now we said that the zinc undergoes oxidation. When we are talking about oxidation, the zinc undergoes oxidation, meaning to say the zinc atom will release electron. Okay, so why you start from the zinc? Because the zinc here, this is the zinc who take part in the reaction, who undergoes oxidation. That's why you are writing the zinc. Okay, release electrons, it will form Zn2 positive. Minus electron on the left, you bring onto the other side, it becomes plus. Okay, balance up the equation. 1 zinc, 1 zinc. 2 positive, 2 electrons. Okay, and from here, what will be the observation? When oxidation occurs, the observation will always be the zinc electrode becomes thin. I repeat, when we are talking about oxidation that occur, normally the observation will be the zinc electrode becomes thinner. The keyword, thinner. No writing about becomes smaller or it dissolves. No. You will only see it becoming thinner. Okay, so please remember about this word. I put a love for you. Remember, please. Okay, so this is the analysis that we get from the picture. Now see whether the analysis that we have done relates to our question or not. Okay, I hope you are okay with this. Please jot down next to the diagram that you have. Now I'm going to continue. I'm going to clear all this and I'm going to share with you the question. Okay, now the question. Oops. Please wait. Okay. Okay, please wait for a while. Okay, now again, the observation, the zinc becomes thinner. Second part, for the half equation, this is the half equation. Zn becomes Zn2 positive plus 2 electrons. Okay, now next part of the question. Next part of the question says that if the zinc electrode if the zinc electrode is replaced with a magnesium electrode, what will happen to the potential difference of the cell? So now what are we going to do is we are going to look at the location of the zinc and the magnesium in the electrochemical series. Please note, please jot down the electrochemical series from the potassium. Okay, this is the continuous part. This is the electrochemical series. Okay, now we continue. What we want to see is this. What we want to see is this, the zinc and the magnesium, okay, with the copper down here. I am going to put the blue for the copper. The copper down here. Okay. Now we are going to get the distance. Okay. The distance, see, from the magnesium to the copper, and second one from the zinc to the copper. Can you see the difference? First set, we are using the zinc and the copper. Second set, we are using the magnesium and the copper. Which is of further distance? Of course, from what we see here, the magnesium and the copper is further away compared to the zinc and the copper. Therefore, when we are talking about the potential difference, of course, the potential difference which is produced by set 2, which is using magnesium and copper, is higher. Okay, so we have get 1 mark. The potential difference that is produced increases or it becomes higher. Please don't write the word high because it does not show any comparison. Now we are going to explain why. So what is the explanation? The explanation is this. The answer is here. We are going to talk about the distance. So the distance between the magnesium and copper in the electrochemical series is further than the distance between the zinc and the copper. Okay, now what I want you to see here will be, you are talking about this number set 1. You are talking about this, the set 1, magnesium and copper, and for set 2, zinc and copper. Okay, you are comparing this, comparing about the metals that you are using. Which series are you referring to? You are referring to the electrochemical series. Okay, so I hope you can do this correctly. Okay, any problem? I hope you're okay. Now, let's move on. For your information, this is not a difficult question. Okay, these are quite easy. Now, we move on to our next question, where we are talking about this. Okay, our next question, we are actually talking about the part C. The table shows observation at the anode, the keyword anode, when concentration of sodium chloride solution are electrolyzed using carbon electrodes. The factor, different concentration. This is the MV. This partner, this is the MV. Okay. This is the CV, control variable. Okay. Now we get observation that happened at the anode, where actually we relate to the products formed at the anode. This is actually the RV. Okay. Now, can you see this number 1.0? What can you tell about this 1.0? Yes, this is actually concentrated solution. Okay. Now, this one is a dilute solution. Now, see, when this is concentrated solution, we are talking about the anode. So, what are the anions which is being selectively discharged? So, in sodium chloride solution, The ions, now we are talking about anode, so we go for the N ions. The N ions will be the chloride ion and the hydroxide ion. Now, if it is concentrated and there is a halide, can you see this to be the halide? So this will be selectively discharged. That's why you are getting a yellowish green gas is released. Now, if it is a dilute solution, so straight away you choose the ion which is lower in the electrochemical series, which is the hydroxide solution. So the ion which is selectively discharged for set 1 will be chloride ion, and the ion which is being selectively discharged in set 2, the N ion, is the hydroxide ion. Therefore, you get colorless gas bubbles released. Now, part 1. Write half equation for the reaction that occur at cathode for cell 1 and cell 2. Okay, so now for cathode at cell 1 and cell 2, this one, cathode. So we are actually looking at the cation ions. Now, what are the cation ions that present? From the sodium chloride solution, you are having the sodium ion and the hydrogen ion. I hope you agree with me. And the hydrogen ion is actually lower in the electrochemical series. And straight away, we are going to put it to be selectively discharged. So for the half equation for the reaction at cell 1 and 2, so you are going to write cell 1. The hydrogen ion selectively discharged, ion will become a molecule or an atom. The plus here, so you plus electron. 2 hydrogen on the right, here 2, so you put a 2. 2 positive, 2 electrons. Okay, and actually if we are talking about set 2, you are actually getting the same answer for set 2. You are just writing back the same thing. Okay, 1 correct, 1 mark. Next part. Based on table 7, which is this table, you are going to explain the observation. What is the observation? Yellowish green gas and the colorless gas bubbles. And you are going to name the product form at the anode and at the anode for cell 1 and 2. Now I have a suggestion. In writing the answer for this, you can actually put it into a table form. Okay? Now what can you put? You can put here as cell 1 and cell 2. Okay? I am going to share with you this whiteboard so that you can see it clearly. Now, this is the whiteboard showing. Okay, this should be your table. This can be your title. Okay. Now, you can put here as the cell. Okay, then you can put here as 1. And you can put here as 2. Now, from the question, it says that they want you to state the product form. You explain the observation and you name the product form. We can actually put here the product first. Okay, what is the product? For cell 1, yes, it will be the chlorine gas. So, chlorine gas. Okay, now for cell 2, it will be the oxygen gas. Okay, now how do you get the chlorine gas and the oxygen gas? I've already mentioned many times. Whenever you have a chance to write your half equation, you please write. So you can put here half equation. Okay, what will be the half equation here? You can actually write it. So I'm writing for you for this part. For the chlorine gas, the chloride ion becomes the Cl2 plus 2 electron. Okay, for this, you are going to have your hydroxide ion selectively discharged. You are getting H2O and oxygen. Balance up the equation, you put a 2, you put a 4, and a 4 here. Now, how do you come to this selectively discharge of this? So, we are going to write your reason here. What is the reason? Then you can say the reason. First part, what can you tell? You can say that the chloride ion is selectively discharged at anode. Okay, so this is your answer for set 2. Then you are writing the similar thing for set 1. You have already written this. Now for set 2, you can write the similar thing, but this time you are going to tell that the hydroxide ion is selectively discharged at anode. Okay. When you have already written it is selectively discharged at anode, we are going to tell why. Why is it selectively discharged at anode? Okay. Now we continue. What is the reason? Here for this case in set 2, you are going to say that hydroxide ion is lower than the the chloride ion in the electrochemical series. Okay. Please remember to spell out the electrochemical series. This is the answer for set 2. Now, what about the set 1? This time, we are going to write, why is the chloride ion being selectively discharged? The factor is the concentration. Therefore, we are going to say the concentration of chloride ion is higher than the hydroxide ion. Okay, please no telling that the solution is a concentrated solution and there is halide ion. No, you have to straight away directly tell that the concentration of the chloride ion is higher than the hydroxide ion. Okay, now please take note. Look at the flow that I am talking about. First, we write about the formation of the product on both sides. Okay, then we write half equation, because the half equation will tell us how do we get the chlorine gas and the oxygen gas. And next, we are going to write why is this chlorine gas is produced. Why do you get such half equation? We are going to say that, the chloride ion is selectively discharged. Why is it selectively discharged? It is due to the concentration, which is higher. Now for set 2, why do you get such half equation? The hydroxide ion is selectively discharged. Why do you get hydroxide ion to be selectively discharged? The reason is it is lower than the chloride ion in the electrochemical series. Please remember to put the word electrochemical series. Okay, so this is your answer. Now, an extra question for you. If I want you to test for the presence of the chlorine gas in set 1, how are you going to test? I repeat, I'm going to give you the question. State a chemical test for the presence of chlorine gas. Okay, how do you test? Any idea? Okay, now I'm going to guide you through. Now previously we have already mentioned about this. We relate to our chapter 4 in Form 4. So how are we going to test it? Number 1, we are going to use the litmus paper. We are going to use the blue litmus paper. So place a blue litmus paper at the test tube, which contain chlorine gas. You please spell it in full. Okay. Now, at my statement here, there is one error. What is the error? I hope you get this. It should be place a moist here. Moist blue litmus paper. The word moist must be there. Okay. Now, what do you do next? What do you see? You will see that the moist blue litmus, we are now going to write our observation. Okay. So you are going to see that the moist blue litmus paper turns red. Okay. Then bleached. No turning colorless, please. Okay. Now, this is the observation. Now, I want you to recall when we are writing a chemical test, number one, we are going to use the method. Start with the word place and action. What is the substance that you are using? Moist blue litmus paper. Then we are going to write the observation. The pink color here will be the observation. Okay. Now, what does it show? It actually shows the presence of the chlorine gas. Okay. Now, why do you have the blue litmus paper turns red then bleach? The reason is like this. I've already mentioned this when I'm talking about our Form 4 Chapter 4, where when you have chlorine gas, the chlorine gas you put into water, actually it will produce the HCl and the HOCl. I put it in line so that you can see clearly. Actually, when the chlorine is put into water, you are getting HCl and HOCl. This HCl is the hydrochloric acid. That is the one which give you the red. This one, the red. Okay. Now, the HOCl, the hypochlorous acid, is the one which has bleaching properties that makes it to bleach off. Okay, I hope you can understand what am I talking about. That's why you get the observation, blue litmus paper turns red, then bleach. If you have forgotten about this, please refer to your periodic table, the reaction of chlorine gas or the halogen with water. Okay, so I think with this, we have completed our this discussion on the question 7. Okay, with this, we have completed our discussion on question 7. I hope you can understand, and if you have any problem, please text me. The next lesson, we are going to talk about the how to answer essay question regarding the rusting of iron and also a part of the redox reaction, which is question 8. Please stay tuned. See you next time. Bye. Thank you.